See, Standard 10th Maths, Chapter 1, Relations and Functions. We are going to see 2 mark questions, important sums in this chapter. The first question is, define a function. Define a function. We say a relation is a function. The relation only we say it is a function. A relation f between two non-empty sets. Two non-empty sets x and y is called a function. Is called a function from x to y. From x to y if for every element x in x, if for each x in x there exists an element, there exists only one element. Let me represent that as y in y such that we define that relation as the order pair. X comma y is in f. So for every element x in x, we see there exists only one y in y such that order pair x comma y is in f. That is, we can also define that it is set of all the order pairs x comma y such that for all x in x and y in y. The function from f(x) to a function f from x to y we defined as f is from x to y. This is the definition. Next is define real valued function. Already we seen the definition of function. A function f is from x to y. Here let me take a to b is called a real valued function. Real valued function if the range of f is a subset of real numbers R. Subset of real numbers set R. That is, we say f of a is contained in or equal to real number for all a in a. For all a in a. So we defined, we get all the images are in the set R. So this is called the real valued function. Find k, third sum. Find k if f dot f of k is equal to 5, where f of k is equal to 2k minus 1. So take the left side, f dot f of k first. This is f of k is 2k minus 1. Now this becomes f of k. We replace k as 2k minus 1 in the definition. 2 into 2k. We replace that as 2k minus 1 minus 1. So 2 2s are 4k minus 1 2s are 2 minus 1. So 4k minus 3. So what is given? Given this f dot f of k is 5. So 4k minus 3 is equal to 5. So 4k is equal to 5 plus 3. So 4k is equal to 8. So k is 8 by 4. So k is equal to 2. This is the answer. See, fourth sum. A relation f is from x to y is defined by f of x equal to x squared minus 2, where x contains the element minus 2, minus 1, 0, 3 and y is equal to r, that is y is set of real numbers. List the elements of f. So the function f is from x to y. We defined f of x is equal to x squared minus 2. We take the element of x from the set x. First let me take minus 2. So that is minus 2 the whole square minus 2. Minus 2 the whole square, 4 minus 2 is 2. Next 1. F of minus 1. So minus 1 the whole square. Replace x as minus 1. Minus 2. Minus 1 the whole square is 1 minus 2. That is minus 1. Then take 0. F of 0. That is 0 squared minus 2. 0 squared is 0 minus 2. That is minus 2. Next is 3. Replace x as 3. That is 3 squared minus 2. 9 minus 2, that is equal to 7. So in the given list the elements of f. So the elements of f are order pairs. When I substitute x as minus 2, I am getting the value as 2. Then for minus 1, you are getting the image also minus 1. 0 minus 2. 3, 7. So this is the answer for the first question. Second question is f is a function? So, see, in order to check that f is a function, just you see whether this f mapped the elements or from the set real numbers. Yes. So, we see all the images of f. That is the second element in the ordered pair are real numbers. Therefore, it is a function. Yes, f is a function. F is a function. Because all the images under f are elements from R. So, we say it is a function. See the fifth sum. If x is minus 5, 1, 3, 4 and y is equal to the set A, B, C, then is the relation Rs minus 5b, 1b, 3a, 4c is a function from x to y. See the elements of the relation. See, minus 5 is mapped on to b from the set y. Then 1 is mapped on to the element b, that is from the set y. 3 to a, that is also from the set y. Then 4 mapped on to c from the set y. See here, each element of this x has an unique image in y. Therefore, Rx is a function. This relation is a function. So you can draw this in the arrow diagram also. See, in the arrow diagram, all the elements of the set X has the images, unique images in the set in the codomain Y. So therefore, it is Rx is a function. We say this is a function. Rx is a function. It's a function. The reason is each element of X has, say, unique image in y. See the next sum. Let f be a function from R to R, defined by f of x is 3x minus 5. Find the values of a and b, and also they given the order pair a is mapped onto 4 and 1 is mapped onto b. You find the value of a and b. Given f is a function from R to R such that f of x is 3x minus 5. So here a comma 4, that is f of a is equal to 4. So what is f of a? Replace x as a, 3a minus 5. This is equal to 4. So 3a is equal to 4 plus 5. 3a is equal to 9. So a is equal to 9 by 3. So a is 3. Next is 1b. 1 comma b. That is f of 1 is equal to b. So what is f of 1? Replace x as 1. 3 into 1 minus 5 is equal to b. So 1 3s are 3 minus 5 is equal to b. That is minus 2 is equal to b. So the value of a is equal to 3 and value of b is equal to minus 2. That is your question. See, let f of x is 3x minus 2, g of x is 2x plus k, and if f dot g is equal to g dot f, then find the value of k. So given f of x is 3x minus 2 and g of x is 2x plus k. First find f dot g. F dot g is g of x. That is f of g of x is 2x plus k. Then what is f of x? 3x minus 2. 3. Replace x as 2x plus k minus 2. 3 2s are 6x plus 3k minus 2. That's all. We cannot further simplify this. Now take g dot f of x. That is g of f of x is 3x minus 2. G of x is replace x as 3x minus 2 plus k. So 6x minus 4 plus k is given f dot g is equal to g dot f. So equate both the right side terms. 6x plus 3k minus 2 is equal to 6x minus 4 plus k. So you collect the x term and then this 3k. So this x from the right side you bring it to the left side, minus 6x k plus k becomes minus k. You keep the constant on the right side itself, it is 4. We are going to transfer this minus 2 to the other side, so plus 2. 6x cancel. 3k minus k is 2k minus 2. So k is equal to minus 2 by 2, that is equal to minus 1. So the answer of k is minus 1. See next sum. If A cross B is set of order pairs, 4 order pairs, find A and B. See in the order pairs, the first element are from the set A. So in that case, I collect all the first element of the order pair. Here 3. Again in the second order pair 3, so we need not repeat the element. Then the first element here is 5. So set A is 3, 5. Collect the elements from the set B, second element 2, and again here the second element 4. That's all. So the other two order pairs, the second elements are repeated, so don't need to write. So the set A is 3, 5 and set B is See the next sum. Set A is 1, 3, 5 and B is 2, 3. Find A cross B. So A cross B is equal to A is 1, 3, 5 cross B is 2, 3. So that is collection of order pairs. We take the first element from the set A. So 1, 2, then 1, 3. Take the second one, 3, 2, 3, 3. 5, 2, 5, 3. Set B cross A. B is 2, 3 cross A is 1, 3, 5. So 2, 1, 2, 3, 2, 5. Then second element 3, 1, 3, 3, 3, 5. So this is the answer. See the sum. B cross A is given as minus 2, 3, minus 2, 4, 0, 3, 0, 4, 3, 3, 3, 4. Find A and B. See, this is often repeated question. It is in the first exercise, but anyway, I'll do for you. See the set, partition product. B is the first set. So, in the order pair, the first element are from the set B. So, first you collect the first elements. Minus 2. Here minus 2 is repeated. Don't write 0. Again 0 is repeated. 3. So, minus 2, 0, 3. Second set is A. Second element of the order pair 3, then 4. See 3 repeated, 4 repeated, again 3, 4 repeated. So the set A contains the element 3, 4. See, this is often repeated question. So you can mark this as important one. 11th sum. A relation R is given by the set R, order pair xy, where y we get it from x plus 3. Substitute the value for x and add the constant 3, you will get the value for y. So it determines its domain and range. Domain is the set x. Range, the answer we are getting. So already this sum is done for you. It is in page 9, exercise 1.2, sum number 3. So this sum is given as a video for you. You can do that. See, represent the function. The function is given for you all the order pairs. You have to represent, this is a order pair representation. You have to represent this in the arrow diagram and in the table form. So this sum you will get in page 25, exercise 1.4, sum number 3. See the next question. Let A is 1, 2, 3, 4 dot dot up to 45. And R be the relation defined on the set A as the square of a number. And also R subset of A cross A. Find the domain and the range of R. This is square of. So this sum is given in page 9, exercise 1.2. This is the second sum in that exercise. You can watch this in the video. See the next sum. If f of x is 3x plus 2, g of x is 6x minus k, find the value of k such that f dot g is equal to g dot f they given. This is also exercise sum. It is in page 31, exercise 1.5. Sum number 2. Sum number 2, it is in the first division. So you can go through the sum in the video. See 15th sum. If A is equal to B, that both the sets are the set PQ. Find A cross B and A cross A. This is also the exercise sum. It is in page 6. First exercise, exercise 1.1. The first sum, but in the second subdivision. If f of x is 3 plus x, g of x is x minus 4, check whether f dot g is equal to g dot f. This is also the exercise sum. It is in page 31, exercise 1.5, first sum, fourth subdivision. See the next question. Find A cross B. A is 2 minus 2, 3 and B is 1 minus 4. So first exercise sum. See, all these are simple sum but important. Next 18th sum. Let A is 1, 2, 3 and B is given in the set built-up form. The set of all x such that x is a prime number less than 10. The set B contains all the prime numbers. See, 1 is not a prime number. It's neither a prime number nor a composite number. The prime number starts from 2. 2, 3, 5, 7. Only 4 elements you have. You find A cross B and B cross A. It is in page 6. Exercise sum. First exercise sum 2. See, let A is minus 1, 1, B is 0, 2. If the function f is from A to B, defined by f of x is ax plus b, is an onto function. Find A and B. See, this is also exercise sum. It is in page 25. Exercise 1.4. Eighth sum. Very important sum. See the next sum. Let f of x is 2x plus 5. If x is not equal to 0, then find f of x plus 2 minus f of 2 by x. So this is also an important sum. It is in page 14. Exercise 1.3, sum number 5. See the next sum. Given the function f is from x to x square minus 5x plus 6. So x is mapped on to this equation. So evaluate, find the value of f of 2. Replace x as 2 and f of x minus 1. Replace x as x minus 1 and you calculate and write. It is in page 14. Exercise 1.3, sum number 3. Let A is 1, 2, 3, 4 and B is the set natural numbers 1, 2, 3 dot dot dot. F is from the set A to B and also f of x equal to x cube. That is, if I substitute x as 1, 1 cube. 2 means 2 cube 8 you will get. Find the range of f. Identify the type of function. It is also exercise sum. We have already done this as the video. So you can go through that exercise 1.4, sum number 6. See, let A is 1, 2, 3, 7 and B is 3, 0, minus 1, 7. Which of the following are relation from A to B? Relation R1, R2. You have to find which of the two relations are from A to B. So this is also exercise sum. It is in page 9. Exercise 1.2. Sum number 1. Sum number 1. See the last sum. If f of x is 2x minus 1, g of x is x plus 1 by 2, show that f dot g equal to g dot f is equal to x. And one more sum, 25th one. F of x is x square minus 1, g of x is x minus 2. Find A. If g dot f of A is equal to 1. So these two sums are very important one. So it is in page 31, exercise 1.5, sum 3 and 4. See, I covered all your 2-mark questions. You go through that. The first exercise 1.1 is very important one. Surely you can expect the 2 marks and 5 marks from the first exercise and also examples in that given. And you revise all these sums so that first chapter is completed. Thank you.